Physics chapter 19, new book, thermal physics. So this is actually an extension of what you have learned in O levels. From molecular physics, this has been derived. There are some definitions that you would have to know, and there are some features that you would have to understand before you begin the extension of this. So now if you have forgotten these things, you should revise on that. So here, before you start, they say write down the boiling point and melting point of water. So you have to know uh, uh, what melting point is, what boiling point is, and the names scientists use to describe changes of state. That is, the change from solid to liquid, then liquid to solid, then directly solid to gas. So those names you must know. Um, then boiling points, boiling, freezing, melting, etc. Those things you need to know. Then atoms and molecules, what they are and how particles behave. Then examples for particular nature of matter. So those things you need to know. Then when water boils, it changes its state. It turns into vapor. Then a liquid has become gas. Then you know that it is we can say it as evaporation. Then a liquid can turn itself into a gas by by different processes. For example, if you leave some water in sunlight, it would not boil, but it would simply evaporate. In this particular situation, it vaporizes because it reaches the boiling point. So these details you have to understand. So this is a geyser in New Zealand. So when water comes in contact with hot lava, then it becomes a gas. Then that gas will burst out of the earth. Then this change of state can be actually explained by the kinetic model of matter. So kinetic model of matter explains that materials are in continuous and constant motion. So this constant and continuous motion can depend on certain factors. One factor that materializes, or one factor that defines whether something is going to be a solid, liquid, or a gas, is the kinetic energy that is contained in it. If it has a higher kinetic energy, so it is highly likely that it would be either a gas or a liquid. So a solid would have a small amount of kinetic energy, so as a result it would simply vibrate at a fixed position. But in a gas, they are broken free from their neighbors, so they are widely separated and are free to move around within its container. But in a liquid, it is not actually free to move around its container, but in a fixed volume, it is able to move around, and that is something that you know. So you should be able to answer this question. Describe a liquid in terms of the arrangement of its particles, the bonding between them, and their motion. So this is a question that you should try, and you should find the answer for this. So after you have answering this question, so obviously your answer, you can take a moment and answer this question. And now pause the video and answer the question. So now I'm sure you have written the answer. So the answer should contain something like this. So there is, in here, you can understand, you can actually see the difference between these two. In a solid, the particles are close together. tightly bonded to their neighbors and vibrating about fixed position. In a gas, the particles have broken free from their neighbors. They are widely separated and are free to move around within the container. So a liquid actually has a quality that is in between these two. In a liquid, the particles have not completely broken free from their neighbors. There are some attractions, but they are somewhat separated and are free to move around within a fixed volume, but they are not able to move everywhere. And also they are not arranged in a specific order. They still have the ability of moving around. So then energy changes, this is something that you have learned in O levels as well. When you change the energy content of a material, for example, if you take a solid, and how do you change the energy content of a solid? You can heat it. So when you heat it, the solid will actually melt first. Melt means it will turn itself into a liquid, and then it will absorb more, and if you continue to provide more and more heat, it will turn itself into a gas by boiling. So this energy is the energy that we supply is is related, or there's a vice versa connection with the bonding. So the energy is required to convert them into, or to supply the kinetic energy that is required for this end, for them to escape or break the bonds that exist between them. Now here you can actually see what is happening here. So now this particular object has been, particular material has been, at this point, it is in, at this point A, it is in gaseous state. It is in gaseous state. So then it cools down. It is actually in liquid state because this is octadecanoic acid. So at this point, at point B, it is melted. Melted means it has become a liquid. So at point A, it is a liquid. So at this point, it cools down with time, and then at B, it starts to absorb energy for some time, and nothing is changing. The temperature does not change. Then in this particular period of time, you know what happens to that. So the liquid turns itself into a solid, and then again the temperature drops up until room temperature. So after it has become a solid, from beyond solid, how much you cool it, there is no other change in state, because the matter exists only in three states: liquid, solid, and gas. Then basically what you need to understand is what happens here. So what has happened is the temperature of this liquid has dropped, and then it has dropped for up to a certain point, and then it has remained constant. So during the time that is in this period, from B to C, you can see that there is no change in temperature. So the reason is it still actually it eliminates heat energy, but that energy, the temperature drop, that heat energy is actually used to change the state. That is what you need to understand. So here they say the temperature drops rapidly at first, then more slowly as it approaches room temperature. The important section of the graph is the region BC. The temperature remains steady for some time. The clear liquid is gradually returning to its white waxy solid state. It is essential to note that energy is still being lost even though the temperature is not decreasing. When no liquid remains, the temperature starts to drop again. So at this point, so when there is a change of state, there is no change in temperature, but that does not mean that the energy is not being lost. So energy is given away, but the temperature remains steady, because at that point, from B to C in this graph, the state is changing. So then when the temperature remains constant, we know that that particular temperature is the melting point of that particular material. So in this particular situation, we have taken octadecanoic acid, and in octadecanoic acid, the temperature remains constant between B and C. So that fixed temperature is going to be the melting point of this octadecanoic acid. So that is a way, that is actually a technique that you can use to find the melting point. And the purpose why we need to find that melting point or boiling point of certain substances is because we can clearly identify materials if we know their melting points and boiling points. For example, if there is a clear liquid, and if you want to find out whether it is water, what you can do is you can boil it. If it boils at 100 degrees Celsius, you know that it is water. Right. In some ways, it is easier to think of the experiment in reverse. So what we do is we are going in reverse. What will happen if you heat a substance? So now you take some ice, and then you heat it, right? In this particular example, so we have from A to B. So ice has heated to become a liquid. So from B to C, you know that it is melting. Then C to D, it increases its energy up until 100 degrees Celsius. At 100 degrees Celsius, it begins to boil. And by E, there is no water. It's all vaporized. So from E to F, it is water vapor, fully water vapor. Right? DE is between D and E. It is in a media, that is in a medium medium condition or a state which water exists in the form of liquid as well as gas. So by E, all of the water has completely turned itself into a gas, and after that there is no water remaining in it. So from after E, it is fully water vapor, and this vaporized or evaporated vapor will actually continue to increase. If we continue to supply energy, it will continue to increase its heat content. So that is the reason why if you get burned by hot water, and if you get if another person gets burnt by water vapor is actually much more dangerous. It is much more hurtful, because it can hurt a lot, because there is the energy content in water vapor, this evaporated water, is actually much more. So that is something that you need to understand. I hope you understood this. We will write the note and then come back to this. I will give you the note in the next video.